This is our life with bees. And this is our life without bees. Bees are the most important pollinators of our fruits and vegetables and flowers and crops like alfalfa hay that feed our farm animals. More than 1/3 of the world's crop production is dependent on bee pollination. But the ironic thing is that bees are not out there pollinating our food intentionally. They're out there because they need to eat. Bees get all of the protein they need in their diet from pollen and all of the carbohydrates they need from nectar. They're flower feeders. And as they move from flower to flower, basically on a shopping trip at the local floral mart, they end up providing this valuable pollination service. In parts of the world where there are no bees, or where they plant varieties that are not attractive to bees, people are paid to do the business of pollination by hand. These people are moving pollen from flower to flower with a paintbrush. Now, this business of hand pollination is actually not that uncommon. Tomato growers often pollinate their tomato flowers with a handheld vibrator. Now, this one's the tomato tickler. This is because the pollen within a tomato flower is held very securely within the male part of the flower, the anther. And the only way to release this pollen is to vibrate it. So bumblebees are one of the few kinds of bees in the world that are able to hold on to the flower and vibrate it. And they do this by shaking their flight muscles at a frequency similar to the musical note C. So they vibrate the flower, they sonicate it, and that releases the pollen in this efficient swoosh, and the pollen gathers all over the fuzzy bee's body, and she takes it home as food. Tomato growers now put bumblebee colonies inside the greenhouse to pollinate the tomatoes because they get much more efficient pollination when it's done naturally, and they get better quality tomatoes. So there's other, maybe more personal reasons to care about bees. There's over 20,000 species of bees in the world, and they're absolutely gorgeous. These bees spend the majority of their life cycle hidden in the ground or within a hollow stem, and very few of these beautiful species have evolved highly social behavior, like honeybees. Now, honeybees tend to be the charismatic representative for the other 19,900 plus species because there's something about honeybees that draws people into their world. Humans have been drawn to honeybees since early recorded history, mostly to harvest their honey, which is an amazing natural sweetener. I got drawn into the honeybee world completely by a fluke. I was 18 years old and bored, and I picked up a book at the library on bees, and I spent the night reading it. I had never thought about insects living in complex societies. It was like the best of science fiction come true. And even stranger, there were these people, these beekeepers, that loved their bees like they were family. And when I put down the book, I knew I had to see this for myself. So I went to work for a commercial beekeeper, a family that owned 2,000 hives of bees in New Mexico. And I was permanently hooked. Honeybees can be considered a superorganism, where the colony is the organism, and it's comprised of 40 to 50,000 individual bee organisms. Now, this society has no central authority. Nobody's in charge. So how they come to collective decisions and how they allocate their tasks and divide their labor, how they communicate where the flowers are, all of their collective social behaviors are mind-blowing. My personal favorite, the one that I've studied for many years, is their system of health care. So bees have social health care. So in my lab, we study how bees keep themselves healthy. For example, we study hygiene, where some bees are able to locate and weed out sick individuals from the nest, from the colony, and keeps the colony healthy. And more recently, we've been studying resins that bees collect from plants. So bees fly to some plants and they scrape these very, very sticky resins off the leaves, and they take them back to the nest where they cement them into the nest architecture, where we call it propolis. We found that propolis is a natural disinfectant. It's a natural antibiotic. It kills off bacteria and molds and other germs within the colony, and so it bolsters the colony health and their social immunity. Humans have known about the power of propolis since biblical times. We've been harvesting propolis out of bee colonies for human medicine, but we didn't know how good it was for the bees. So honeybees have these remarkable natural defenses that have kept them healthy and thriving for over 50 million years. So 7 years ago, when honeybee colonies were reported to be dying in mass, first in the United States, it was clear that there was something really, really wrong. In our collective conscience, in a really primal way, we know we can't afford to lose bees. So what's going on? Bees are dying from multiple and interacting causes, and I'll go through each of these. The bottom line is, bees dying reflects a flowerless landscape and a dysfunctional food system. Now, we have the best data on honeybees, so I'll use them as an example. In the United States, bees, in fact, have been in decline since World War II. We have half the number of managed hives in the United States now compared to 1945. We're down to about 2 million hives of bees, we think. And the reason is, after World War II, we changed our farming practices. We stopped planting cover crops. We stopped planting clover and alfalfa, which are natural fertilizers that fix nitrogen in the soil. And instead, we started using synthetic fertilizers. Clover and alfalfa are highly nutritious food plants for bees. And after World War II, we started using herbicides to kill off the weeds in our farms. Many of these weeds are flowering plants that bees require for their survival. And we started growing larger and larger crop monocultures. Now, we talk about food deserts, places in our cities, neighborhoods that have no grocery stores. The very farms that used to sustain bees are now agricultural food deserts dominated by 1 or 2 plant species like corn and soybeans. Since World War II, we have been systematically eliminating many of the flowering plants that bees need for their survival. And these monocultures extend even to crops that are good for bees, like almonds. 50 years ago, beekeepers would take a few colonies, hives of bees, into the almond orchards for pollination, and also because the pollen in an almond blossom is really high in protein. It's really good for bees. Now, the scale of almond monoculture demands that most of our nation's bees, over 1.5 million hives of bees, be transported across the nation to pollinate this one crop. And they're trucked in semi-loads, and they must be trucked out because after bloom, the almond orchards are a vast and flowerless landscape. Bees have been dying over the last 50 years, and we're planting more crops that need them. There has been a 300% increase in crop production that requires bee pollination. And then there's pesticides. After World War II, we started using pesticides on a large scale, and this became necessary because of the monocultures that put out a feast for crop pests. Recently, researchers from Penn State University have started looking at the pesticide residue in the loads of pollen that bees carry home as food. And they found that every batch of pollen that a honeybee collects has at least 6 detectable pesticides in it. And this includes every class of insecticides, herbicides, fungicides, and even inert and unlabeled ingredients that are part of the pesticide formulation that can be more toxic than the active ingredient. This small bee is holding up a large mirror. How much is it going to take to contaminate humans? One of these class of insecticides, the neonicotinoids, is making headlines around the world right now. You've probably heard about it. This is a new class of insecticides. It moves through the plant so that a crop pest, a leaf-eating insect, would take a bite of the plant and get a lethal dose and die. If one of these neonics, we call them, is applied in a high concentration, such as in this ground application, enough of the compound moves through the plant and gets into the pollen and the nectar, where a bee can consume, in this case, a high dose of this neurotoxin that makes the bee twitch and die. In most agricultural settings, on most of our farms, it's only the seed that's coated with the insecticide. And so a smaller concentration moves through the plant and gets into the pollen and nectar. And if a bee consumes this lower dose, either nothing happens or the bee becomes intoxicated and disoriented, and she may not find her way home. And on top of everything else, bees have their own set of diseases and parasites. Public enemy number one for bees is this thing. It's called Varroa destructor. It's aptly named. It's this big blood-sucking parasite that compromises the bee's immune system and circulates viruses. Let me put this all together for you. I don't know what it feels like to a bee to have a big blood-sucking parasite running around on it, and I don't know what it feels like to a bee to have a virus. But I do know what it feels like when I have a virus, the flu. And I know how difficult it is for me to get to the grocery store to get good nutrition. But what if I lived in a food desert? And what if I had to travel a long distance to get to the grocery store, and I finally got my weak body out there, and I consumed in my food enough of a pesticide, a neurotoxin, that I couldn't find my way home? And this is what we mean by multiple and interacting causes of death. And it's not just our honeybees. All of our beautiful wild species of bees are at risk, including those tomato pollinating bumblebees. These bees are providing backup for our honeybees. They're providing the pollination insurance alongside our honeybees. We need all of our bees. So what are we going to do? What are we going to do about this big bee bummer that we've created? It turns out it's hopeful. It's hopeful. Every one of you out there can help bees in two very direct and easy ways. Plant bee-friendly flowers, and don't contaminate these flowers, this bee food, with pesticides. So go online and search for flowers that are native to your area and plant them. Plant them in a pot on your doorstep. Plant them in your front yard, in your lawns, in your boulevards. Campaign to have them planted in public gardens, community spaces, meadows. Set aside farmland. We need a beautiful diversity of flowers that blooms over the entire growing season, from spring to fall. We need roadsides seeded in flowers for our bees, but also for migrating butterflies and birds and other wildlife. And we need to think carefully about putting back in cover crops to nourish our soil and nourish our bees. And we need to diversify our farms. We need to plant flowering crop borders and hedgerows to disrupt the agricultural food desert and begin to correct the dysfunctional food system that we've created. So maybe it seems like a really small countermeasure to a big, huge problem, just go plant flowers. But when bees have access to good nutrition, we have access to good nutrition through their pollination services. And when bees have access to good nutrition, they're better able to engage their own natural defenses, their health care that they've relied on for millions of years. So the beauty of helping bees this way, for me, is that every one of us needs to behave a little bit more like a bee society, an insect society, where each of our individual actions can contribute to a grand solution, an emergent property that's much greater than the mere sum of our individual actions. So let the small act of planting flowers and keeping them free of pesticides be the driver of large-scale change. On behalf of the bees, thank you.
Thank you. Just a quick question. The latest numbers on the die-off of bees, is there any sign of things bottoming out? What's your hope/depression level on this?
Yeah, at least in the United States, an average of 30% of all beehives are lost every winter. About 20 years ago, we were at a 15% loss. So it's getting precarious.
That's not 30% a year, that's 30%.
Yes, 30% a year.
30% a
but then
year.
beekeepers are able to divide their colonies, and so they can maintain the same number. They can recuperate some of their loss. We're kind of at a tipping point. We can't really afford to lose that many more. We need to be really appreciative of all the beekeepers out there.
Thank you.
Flowers.
Thank you.